So now we're talking about that shortcut of finding a z-score to solve these problems. Remember, the general normal curve looks like this. We have the mean plus the standard deviation, the mean plus 2 standard deviations, the mean minus 3 standard deviations. Oh, excuse me, plus 3 standard deviations. Then we have the mean minus a standard deviation, the mean minus 2 standard deviations, and the mean minus 3 standard deviations. Since the percentages all stay the same, we said it would certainly be nice if for all these different data sets that are normally distributed, rather than having to create a normal curve for each data set like we did here, it'd be great if we could just work off of this normal curve, and now we can. Finding the z-score for machine 2 means taking the data value in question, this time it's 12.28, subtracting off the mean of 12, and dividing by the standard deviation, which was 0.14. Just to remind you, how do I know that the data value in question is 12.28? Well, that's what we were being asked about in the problem. The mean and standard deviation were previously calculated. All right, simplifying this fraction, we get 0.28 in the numerator and 0.14 in the denominator. Dividing gives us 2. How do we use that on our general normal curve below? Well, a z-score of 2. That means that we are 2 standard deviations to the right of the mean. Here's the mean, 2 standard deviations to the right puts us here. The question asked what percent of pop bottles would be filled at least this amount. So at least implies we want to be equal to or greater than. So we want to be above this point, which gives us 2.35% of the data. This is exactly the answer we got when we did it the long way on the specific normal curve. So if you recall, here's all these percentages. We'll just plot those in there that stayed intact. We located the data value of 12.28, and living above it gave us that 2.35%. The difference being now, all we need to do is find a z-score and plot ourselves on this one normal curve. We're going to look at finding a z-score for Quinn and the SATs in the very next video.